Welcome you all for the session on conic sections. Conic sections are curves obtained by the intersection of a right circular cone by a cutting plane at different angles. Different types of curves are ellipse, parabola, hyperbola and circle. Consider a cone. This is the cone, and in a cone the top point is always called apex or vertex, and this is the base of the cone, and the central imaginary line is called axis of the cone, and these two lines are called generators. These two lines are imaginary assumed lines, generator, and obviously this is the radius of the cone. With the help of this cone, we can create those different types of curves such as ellipse, parabola, hyperbola and circle. How we can create? It's very simple. For creating those curves, we need a cutting plane. Normally, a plane is a two-dimensional entity which has no thickness. It has only length and breadth. It has no thickness. The example for a plane is simply a paper. Even though the paper has thickness, when comparing the length and thickness of the length and width of the paper, the thickness is very, very low. So the thickness is always omitted. So we can consider the paper is a plane. It is a cutting plane which is used to cut the cone to create the different types of curves what we have already mentioned. Okay, the first one is a circle. How can we create a circle with the help of this cone? Okay, take the cutting plane and cut the cone in such a way that the cutting plane, this is the cutting plane, the cutting plane is parallel to the base of the cone, and as well as it cuts all the generators, and there will be no any inclination between the cutting plane and the base of the cone. If you cut like this, and the cut portion will look like this in three-dimensional point of view, and obviously you know that it is a circle. It is a circle. The condition for getting the circle is the cutting plane is parallel to the base of the cone, as well as it cuts all the generators in a cone, and the angle of inclination between the cutting plane and the base is equal to 0 because two are parallel. And the circle which we get is mentioned here. This is the circle, and second curve, it is an ellipse. How can we create or how can we construct an ellipse? Same thing, take the cutting plane and cut the cone like this. Cutting plane, which means that it has some angle of inclination with the base, as well as it also cuts all the generators in a cone. If you cut like this, you will be getting an ellipse like this. This is an ellipse. The condition for getting an ellipse is very simple. Take the cutting plane and cut the cone in such a way that the cutting plane is having some inclination with the base of the cone, as well as it cuts all the generators, not the base. It is not cutting the base, it only cuts the generators which are available in a cone. And the ellipse is clearly mentioned here for better understanding. This is an ellipse. And third one, it is a parabola. Third one is a parabola. How can we get parabola? Again, it is very simple. Take the same cutting plane and cut the cone like this. The condition for cutting the cone is the cutting plane should be parallel to one of the generators in the cone. In this diagram, in this representation of the cone, we have two generators. This is one generator, and then the opposite one is also another generator. Consider this is first generator and this is second generator. My section plane or cutting plane is cutting the cone, and the condition is, what I have used is, my cutting plane is parallel to the second generator. It cuts the base also. If my cutting plane is parallel to the second generator, then the cut section will look like this. So this is the parabola. How can we get parabola? It's very simple. Take the cutting plane, cut the cone in such a way that your cutting plane should be parallel to one of the generator. In this case, the second generator, which is available in the left hand side of myself, is parallel to the cutting plane. If I cut the cone like this, then I will get the cut section as a parabola, which I have mentioned or drawn here. And for better understanding purpose, this is the parabola. I will not shade. because you will get confused. And then the last curve is hyperbola. How can we get hyperbola? Take the cutting plane, cut the cone like this. This is your cutting plane, and the angle between the cutting plane and the base of the cone should be 90° right angle. Should be 90° right angle. If you cut the cone like this, then you will get this is your hyperbola, and the hyperbola is given here. This is the hyperbola. If you see, all these four curves, circle and ellipse, are closed curves. Circle and ellipse are closed curves, and in the case of hyperbola and parabola are open curves. Open curves. Then next, how can we construct these curves? For constructing all these four types of curves, circle is very easy. Among all these four types of curves, circle construction is very easy. For constructing circle, you need only one dimension. It is called radius. Only one parameter, radius, is enough for constructing the circle. So it is very easy. When it comes to the case of, when it comes to the ellipse and parabola, hyperbola, you need certain methods to construct these curves. There are various methods are available. Among them, one method is very popular and it is a simple, that is called eccentricity method. By using this eccentricity method, we can easily construct all these three kinds of curves. First of all, what is eccentricity? Eccentricity is simply the amount of deviation of a conic section from being a perfect circle shape. That means how much your curve is deviating from a perfect circle is called eccentricity. Eccentricity is always mentioned or denoted by using smaller case letter e. Small case letter e denotes eccentricity. By using this eccentricity, we can construct all these three types of curves. Eccentricity method. And in this diagram, you can clearly see the circle creation, ellipse creation, parabola creation and hyperbola creation. And eccentricity is denoted by the letter E. If eccentricity E is equal to 0, it means that the curve what I have created is perfectly matches with the circle. In the sense, my E will be 0. At that time, I can say that the created curve is a circle. If my eccentricity value is less than 1, then I can say that my curve is an ellipse. If my eccentricity value is equal to 1, then it is a parabola. If my eccentricity is greater than 1, then it is called hyperbola. It's very important. If E is equal to 0, it is a circle. If E is less than 1, then it is an ellipse. If E is equal to 1, it is a parabola. If E is greater than 1, then it is a hyperbola. Among these four, circle and ellipse both are closed curves. Closed curves. Then the remaining parabola and hyperbola are open curves.